Hi everybody. In this video, we're going to look at the constant acceleration formulae. These are the SUVAT formulae. I showed you in a previous video how we prove each of these. In this video, we'll look at how we can prove these two formulae, and then we'll look at how we can apply them to model motion. So if we begin with this one, you can see there's no final velocity term, there's no v term. So what this tells us is that we can substitute this expression for v into the velocity term in our displacement equation. This will write this velocity in terms of u plus at. So we'll have s be equal to u plus v u plus at, all divided by 2 multiplied by p. We can tidy up our numerator, so we'll have 2u plus at over 2 multiplied by t. And then we can divide each of these terms by the 2. So s will equal u plus at over 2. And then we can expand out this t. So we've got the displacement will be ut plus 1/2 of at squared. And that gives us our equation here. Do you want to try and prove this equation? Notice how there's no t term. So we can substitute this t into here. You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So to substitute this t into here, we need to make t the subject. So if we call this equation 1, we'll divide both sides by the u plus v over 2. So we'll get 2s over u plus v will equal t. And then we substitute this expression with t into this one, which I'll call equation 2. So for 2, we'll have the final velocity v will be u plus a multiplied by t, which is this one, 2s over u plus v. Now we need to make v squared the subject. So we'll multiply every term by this denominator. So we'll have v multiplied by u plus v will be u, lots of u plus v, plus 2as. Then we'll expand out these brackets. So we've got vu plus v squared will equal u squared plus uv plus for 2as. You can see this vu will cancel with this one. So we're left with v squared will equal u squared plus 2as. Okay, how did you get on with that? If we look at how we can apply these now in example 2, this is the final SUVAT equation. You can see we're just using final velocity and it becomes a subtraction. I encourage you to try and derive this yourself. So if we begin with example 2, a ball is moving in a straight line with constant acceleration 3 meters per second. It passes point P with velocity 4 meters per second and later passes through point Q where P to Q is 10. We need to find the velocity as it passes through Q. So if we draw a quick diagram, we've got P and Q. Its velocity at P will be 4 meters per second. The distance between them is 10 meters. And the acceleration, we use a double arrow for acceleration, so we don't confuse it with velocity. So if we organize this into SUVAT, displacement is 10, the initial velocity is 4. We want to work out v, which is at point Q. The acceleration is 3, and we don't know the time. So what we do is we eliminate the equations that involve time. And the one that is left will be the one that we use. So v squared will equal u squared, which is 16, the 4 squared, plus 2 times a times the displacement. So we'll have v squared will equal 16 plus 60. We'll take the square root of both sides, and we get approximately 8.72 meters per second. Let's try question 3. Now we're told that a particle moves along a straight line with constant acceleration, 2 meters per second squared, and the particle moves from 40 meters in 5 seconds. Do you want to try and work out the initial velocity and the final velocity using SUVAT? You can pause the video and come back when you're ready. To identify which acceleration formula we're going to use, we'll identify our SUVAT values. We want to work out the initial velocity. The acceleration is 2. We move 40 meters in 5 seconds. So v is not relevant. If we cross out all the equations that involve v, we're going to use this one. So the displacement will be ut plus 1/2 of a times t squared. We can tidy this up. We'll have 40 will equal 5u plus 25. So 15 will equal 5u. U must equal 3. And now we know u, we can work out the final velocity using any of these equations. I'll use this one. So v will be u plus a times t. So v will equal 13 meters per second. I should have said that here as well. Okay, let's try question 4. So do you want to read through question 4 yourself and then try and work out the time taken between O to B and the speed of a particle at B? You can pause the video and come back when you're ready. Okay, so welcome back. So we know the acceleration is 3 meters per second squared, and at time t equals 0, the particle moves with speed 6 meters per second. So this will be our u value, and the displacement is 54 meters. So we'll work out which formula to use. We've got the displacement of 54, the initial value of 6, the v term isn't relevant, and the acceleration is 3, and we're trying to work out the time. So if we cross out the formula with a v term, then we're going to use this formula. So 54 will equal the u times t plus 1/2 of a times t squared. So now we've got a quadratic, we'll make it equal to 0, and we'll simplify the t squared term. So we've got 3/2t squared plus the 6t minus the 54 will equal 0. And we can solve this on our calculators. We get the time to be approximately 4.3 seconds and negative 8.3 seconds. And the time cannot be negative, so we'll discount that solution. So t will equal 4.3 seconds. Then for part B, the speed of a particle at B. So now we have our time. We can use v will equal u plus at. So we'll have v will be 6 plus 3 lots of at 4.3. When we work this out, we get a final velocity of 18.9 meters per second. Okay? How did you get on with that? Well, thank you for watching. I hope you found that useful. If you want more practice on this, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link tonight in the description below.